Hey guys, this is the video for the Arduino voltage divider command or program. I want to go over some thoughts on this and help you guys out where I can when it comes to troubleshooting. So I just went through about 25 minutes of troubleshooting trying to get this to work. You will too at some point during your career. So using tools to help you out in troubleshooting will really affect the quality and how fast you do the work. So here I have a simple multimeter which allows me to probe the voltage of specific circuits. Multimeter has the COM and voltage output. You want to make sure that they're in the voltage and not the amperage output to read. You have 4 settings here. The 20 volt is usually appropriate. It also has a continuity tester to see if you have a broken wire, and if you ever need to test for a resistor, this is your resistor setting as well. This will also work as a battery tester and a few other things, hence why it's called a multimeter. By taking the probe and probing the locations, I can see that there's about a 2.4 volt drop across this circuit. Additionally, there's about a 4.77 total drop. That tells me from a voltage divider formula that these are equal sized resistors. You can see that I have 3 wires, one powering the circuit here, one acting as the ground, and then one wire here acting as your voltage input. So we have voltage outputs as the circuit, and then we have the input here measuring the voltage in the program. The program here is it's 24, 25 lines long of code. Here I have my variable declaration. Here I have my void setup in which I declare an output and an input. Here I declare the serial monitor, which we'll get to in a second, at a 9600 baud rate, which is pretty standard. So when you're declaring a serial, this will work for most applications. A digital write and voltage high, that turns on this pin 13, as you can see that I declared up here. This A, or analog, is the analog side of the Arduino board, in which it is acting as an input that in the loop program where it's running repeatedly, I have the analog read function as an input, which is then stored as a value, val or temporary value, and serial print the value in volts. So the voltage is read in 1023 bits. That is because this is a 10-bit microcontroller. So 2 to the power 10 is 1024, and since we have the 0th index, it's 1023 values. Here, I'm doing the math to take my value that's going to range anywhere between 0 and 1023 and multiplying it by 5, which is the native voltage of this system. The variable declaration here of float, you can see is allows for greater memory allocation so you don't have rounding error. It's similar to MATLAB where you have variable declarations such as double type and integer type and float type that allow you to declare it how many variables you have. The serial.println is similar to the fprint function, in which I have serial.print, which is serial, the object, and then the command print. The serial monitor is in the top right corner. If I click on that, you can see that it's every 5 seconds, this delay 5000, remember we're working in milliseconds, it is printing the voltage of 2.49, which is pretty close to what we'd expect for 5 volts divided by 2, due to resistance and things like that. So, as you can see, this is a very simple program that allows you to investigate the voltage and essentially create a simple multimeter that allows you to investigate the overall voltage. In the next video, we will be going over how to use this in a potentiometer, which is essentially this, to control a servo motor, and then we'll go over transistors, which are a switch, or an electronic switch.